Hello, and welcome to yet another functions lecture. In our last functions lecture, we talked a little bit about scope, namespaces, and objects, and basically how functions are like Vegas. What happens in them stays in them, unless we ask Python to return it using a return statement. But I want to go into a little bit more detail now because things are a little more complicated than I made it seem in that original lecture. So we know that a function has its own namespace, which means that it basically goes off into its own little room, does all its little functiony things, and then comes back only with the things that we've asked it to return. The way we bring things into a function is through arguments. When we have arguments, we can take objects and put them into the function, and then the function can use them when it's off in its own little world doing its own thing. Then, as we discussed, we can return objects, so there's a clear path to get things into the function namespace and out of it. So here's where things get a little bit more complicated. When we were talking about namespaces before, we had only ever really worked with immutable objects. However, now that we've learned about lists, we actually have mutable objects that we can work with. So let me refine what I said in the previous lecture just a little bit. Objects that are created in functions stay in the functions unless we ask Python to return them by using a return. However, when we change a mutable object like a list, we're not actually creating an object. We're just changing one that already exists. So actually, things work a little bit different for mutable objects than immutable objects like integers and strings. Let's head to Atom to see an example. All right, let's look at this function. So this function definition tells us that myF will take in an object. Then we're going to print the ID, which is basically like the address of that object, and then we're going to reassign x to be 24. So it doesn't matter what x was before, now it's equal to 24. Then we're going to print out the ID of x. All right, let's go ahead and run this. So we have a variable h equals 2. We are going to print out the ID before we even run the function, and then we're going to go ahead and run the function. Let's save and run. Python 3 functions 17 blank. Awesome. Okay, so we can see that before we do anything, h's ID is this. Then when we're running the function, we print the ID before we've done anything. So we can see that before we've done anything inside the function, the ID is the same as it was outside of the function. But as soon as we assign 24 to x, overriding this 2 that we put in there before, now the ID is different. And this really helps us understand what's happening here. Remember, any object that we create inside of a function doesn't exist unless we return it so that we can store it once the function is done running. You can see here that when we take an immutable object like an integer and we reassign it, we're actually creating an entirely new object, and we can tell that by printing out the ID of that object. But things work a little bit differently with mutable objects like lists. Here we have a function myF2, which looks very similar to the function we just did, except for instead of reassigning the entire object, we are just changing one element of the list that we take into our function. As before, we're going to print the ID both before and after we make this change. All right, so let's go ahead and run this. We're going to comment out all of this code and then run. Okay, so here, before we even run the function, this is the ID or the address of h. Inside the function, before we change anything, the ID remains the same. Finally, once we change the first item in the list to be 24, it used to be 1, oh, look, the ID/address is exactly the same. So when we have mutable objects that change inside of a function, we're not actually creating new objects, we're just modifying objects that already existed. Because of this, when you change mutable objects within a function, they actually remain changed outside of the function. Let's prove this to ourselves by printing out h once we're done with that function. So we're going to go ahead and run this, and you can see, even though we didn't return anything, we still have a changed list with 24 as the item at index 0. So remember, if an object is immutable, when we reassign it inside of a function, we're actually creating an entirely new object. And any object that's created inside of a function stays in that function unless we return it. On the other hand, with mutable objects, we're not creating a new object, we're just changing one that exists. And so if you change a mutable object inside of a function, it remains changed even if you don't return it. Let's look at another example of how this might work. So we're going to say def add student, and this is going to take a list of students and student name, which is going to be the name of the student that I want to add to my list. So inside my function, I'm going to say list.append student name. So let's go ahead and have a list. I'm going to say students equals Fraser, Niles, and Daphne. So we have our list. Let's call add student and say the list students, and then we want to add the name Roz. Well, let's go ahead and print out students once we're done. Okay, so you can see that our function, even though it didn't return anything, actually changed our list, and this list remained changed after the function was done running. So just to review, the objects that are created in a function stay in the function only applies when we're creating new objects. It doesn't apply to changing already existing objects. So if an object is mutable, for instance like a list, we can change it inside of a function and it will remain changed even if we don't return it. However, this doesn't work with immutable objects like strings, ints, floats, etc. Finally, I want to talk about returning tuples and lists. So when we have a function, remember we can only have one return statement and we can only return one object. So if we want to return multiple things, we're going to have to return a collection of all of the objects that we want to return. We can do this one way with tuples or lists. So for instance, we're going to import random and then we're going to use it to make a rolling 3 dice function. So we're going to say def roll 3 dice. And it's not going to take any input, but what it is going to do is use the random randint function in order to roll 3 die. So I'm going to say d1 equals random.randint 1 to 6. So it's going to choose a number 1 to 6, just like you would if you were rolling a die. And then we're going to repeat that 2 more times. Now, if I'm creating all 3 of these variables, I might want to return all of them. But remember, I can only technically return one thing. However, I could return a collection of items. For instance, I could return a tuple of these. That's what happens when you say return d1, d2, d3. It's actually going to return a tuple with d1, d2, and d3. So if I wanted to call this, I could say print roll 3 dice, and when we run this, you can see that it rolled a 3, a 3, and a 1. When we return multiple items as a list or as a tuple, we can actually use something called multiple assignment in order to assign all of those different items to multiple variables at one time. Let's go back to Atom and see how that might work. All right, so we still have our roll 3 dice function. Now, we know that we can call it, we've called it before, and it'll return one object, a tuple with all 3 dice values. So one option that we could do is we could say dice tup for tuple equals roll 3 dice. Now, when we do this and we print out dice tup, this is going to be exactly what we did before. It's going to return to us all 3 dice as a tuple. However, what if we want to store these separately? We can do that with something called multiple assignment. If you return a list or a tuple, we can actually set that many variables equal to the output of the function. In this case, we returned a tuple with 3 things. So we could say die1, die2, die3 equals roll 3 dice. There we go. Now, instead of returning a tuple to some variable like dice tup, we're returning each individual variable, the item that is in that index. So the first die will be stored in die 1, the second in die 2, the third in die 3. So we'll say print die 1, print die 2, and print die 3. So when we do this, instead of returning as a tuple, it is going to give us each individual die separately in a variable. All right, let's do one more example. I'm going to define a function called namesplitter, and I'm going to ask someone from their name, and they're going to get their first, middle, and last name. Then I'm going to use the .split method in order to split their name into individual strings. So I'm going to say name sep equals name.split. And then I'm going to return name sep. Now remember, when we return a list, which is what this will be, we can use multiple assignment. So one option I have, let's comment all this out. So one option I have would be to call this and store all of their names as a list in a list. So I could say their names equals name splitter. And then we'll say Chelsea, Mariko, Parlette. And then I'm going to print their names. Beautiful. So when we do this, you can see that their names is a variable that's storing a list with all of the individual names. However, since we know that they're going to give us a first, middle, last, we can use multiple assignment to store those in separate variables. So instead of a single variable that will store all of the names as a list, we could say first, middle, last. This will store the first item of that list in first, the next one in middle, and the final one in last. Let's go ahead and print first, print middle, and print last. Beautiful. So you can see that instead of storing all of the names in a list, it's returned each of them individually to the 3 variables, first, middle, and last. All right, that is all that I have for you. I will see you next time.